Hey everybody, welcome back. This week what we're going to do is we're going to look at the fire flow requirements as detailed in the International Fire Code. Know that there's more to the requiring of hydrants than the distance from the hydrant to the remote part of the building. Alright, so if this is not new to you, I hope it's a good refresher, especially a new refresher on the updated sections of the 15 and the 18 IFC. If it is new to you, I hope that you enjoy.
Fire flow requirements for buildings or portions of buildings and facilities shall be determined by an approved method according to the International Fire Code. Appendix B of the Code is a good example of an approved method for determining fire flow and its duration. Table B105.1 bases fire flow on the type of construction and the square footage of the fire area. It is important to note, though, that the appendices are not considered part of the code unless specifically adopted. Looking at Appendix B, fire flow is defined as the flow rate of water supply measured at 20 psi residual pressure that is available for firefighting. The residual pressure criterion of 20 psi is used because it is the minimum pressure recommended for fire engine use by water authorities in order to minimize the possibility of creating a negative pressure in the water main and the resulting damage to the water supply system. Can you separate the area of a building, thereby reducing the fire flow requirement? Absolutely, but it has to be done with an approved firewall constructed in accordance with IBC Section 706.4. Fire partitions and fire barriers are not acceptable. I recently had a conversation with a fire marshal in Columbia County, Oregon, who posed this exact question. Here you see the fire flow table for 1 and 2 family dwellings, Group R3 and R4s, and townhouses. Up to 3,600 square foot in size, you've got a fire flow requirement for 1,000 gallons a minute for 1 hour at 20 psi residual. Greater than 3,600 square foot, you're going to actually have to go by the commercial table that we'll see next. If you install a 13D sprinkler system, then you can actually cut the fire flow requirement in half, as you'll see below. This table is the commercial fire flow table, and as you can see, it's based off of square foot of the building, construction type, and once you put those together, you can actually work to the right and see the actual fire flow requirement and the duration at 20 psi residual. So now let's look at an example to try to draw it all together. What is the required fire flow for a 13,000 square foot Group M building of 2B construction? Looking at table 105.12, we'll work from left to right from the top and we get over to 2B construction. Then we come down to the section that says 12,601 square foot to 15,400 square foot. Once we're there, we work to the right and we can see the actual fire flow in gallons per minute that's required, which is 2,500 for 2 hours. Part 2 of this is, what if the building is equipped with an NFPA 13 sprinkler system throughout? Looking at table B105.2, for buildings other than 1 and 2 family dwellings, Group R3s and R4s, and townhouses, you'll work from the left to right. You'll see section 903.311 of the International Fire Code, which is a 13 system, is what we're going to look at. We'll see that we need to calculate 25% of the value if a 13 system is installed. So that's what we do. But also we got to know that the minimum is 1,000 gallons a minute for a 13. So let's work it out. A 13,000 square foot Group M building of 2B construction would have a fire flow requirement of 2,500 gallons per minute for 2 hours. If we take 25% of that for the 13 sprinkler system, we'll actually have a fire flow requirement of 625 gallons per minute. We know because of footnote 8 that we cannot accept that. We have to default to 1,000 gallons per minute as indicated. Once I know my fire flow requirement, which is in this case 1,000 gallons a minute, I go to table C102.1 to determine the number of hydrants required. So as you can see, I'm less than 1,750. So I look over, I've got 1 hydrant required. I've got 500 is my average spacing between the hydrants, and the maximum distance from any point on a street or road frontage to a hydrant is 250. You might ask, well, what if I didn't have a sprinkler system required and my fire flow requirement was still 2,500? Then, as you can see, 3 down from the left, at 2,500, I would have had 3 hydrants required. My average spacing between hydrants would have dropped from 500 to 450, and my maximum distance would have dropped from 250 to 225. When determining the water supply for buildings equipped with an automatic sprinkler system, know that you do not look at the fire flow requirement and the sprinkler system requirement cumulatively. You look at them independently. What the fire code says is that the water supply shall be capable of supplying the greater of either the sprinkler system demand or the required fire flow. So what you'd have to do is determine which one's greater, and that's going to be what tells you what the water supply should be. In closing, I want you to know that information regarding water supplies for firefighting purposes in rural and suburban areas in which adequate and reliable water supply systems do not exist, the fire code official is authorized to utilize NFPA 1142 or the International Wildland Urban Interface Code. Thank you for being with me this week, and I look forward to coming back with you with a new topic next week.